A single molecule of atmospheric nitrogen collides with the angled asphalt of a suburban roof. It cannot pass through the shingle. It is compressed, forced upward, violently accelerating along the pitch until it tears across the crest. We look at our homes and perceive static umbrellas designed merely to deflect rain. We are blind to the physics. Your roof is a dormant aerodynamic engine. In the bitter autumn of 1957, a Welsh roofer named Gareth Pugh climbed onto a wind-battered farmhouse near the Brecon Beacons. He bolted an $18 sheet of curved metal directly to the ridge cap. This was not a towering, three-bladed turbine. It was a half-cylinder, cut and bent by bare hands, engineered to intercept the wind that perpetually slides up the slope of a pitched roof and accelerates over the peak. By dawn, in breezes logged by the local meteorological station at a mere 11 miles per hour, that strip of raw steel drove a small dynamo. It generated enough rotational force to keep 2 filament bulbs lit inside the kitchen. Pugh recorded this phenomenon in a modest regional builder's circular. Then, the note vanished. The design vanished. For almost 50 years following that autumn night, an identical deception was fed to every homeowner across Britain and America. We were instructed that domestic wind harvest requires a colossal tower erected in the soil, municipal permits, structural engineers, and an extortionate capital drain of $12,000 to $30,000. Why? Because the ridge of your roof, the single most violently wind-rich plane of real estate you own, was systematically amputated from the residential energy conversation. The very institutions that excised it are currently processing your $20,000 solar array installations. Let us examine the mechanical reality of an $80 ridge turbine. Let us quantify why it fundamentally outproduces a photovoltaic panel by as much as 220% within the identical spatial footprint. And let us observe how the corporate energy sector has spent 2 decades pretending this physical mechanism does not exist. We begin with fluid mechanics, because physics is immune to marketing. When wind mass strikes the vertical wall of a domestic structure, it does not stop. It climbs. The incline of a standard pitched roof, precisely between a 412 and a 912 gradient, operates identically to the leading edge of an aviation airfoil. The atmospheric mass accelerates furiously up the windward slope. As it breaches the ridge, its velocity exceeds the ambient ground-level wind speed by 30 to 80%. This is not theoretical modeling. This is empirical fluid dynamics. The building research establishment in Watford, England, cemented this in a 2009 wind load study. The National Renewable Energy Laboratory in Golden, Colorado, mirrored these exact findings between 2011 and 2013. NREL's technical document number TP5000564448 contains the verdict. Ridgeline wind velocities on mundane suburban architecture exceed backyard pole-mounted anemometer readings by an average of 46%. 46%. That is multiplied kinetic energy, silently pooling above every house in the country, and almost no one is harvesting it. Consider the mathematical consequences. If the ridge of your roof experiences nearly 50% more wind velocity than your backyard, and aerodynamic power scales with the cube of velocity, a 46% speed increase yields a 312% amplification in harvestable wattage. Why, then, has the residential renewable apparatus spent 20 years planting metal towers in the stagnant boundary layer of your dirt backyard, ignoring the high-velocity apex? Follow the capital. In 2006, a minor British enterprise called the Power Collective filed a patent for a mechanism termed the Ridgeblade. It was Gareth Pugh's 1957 schematic resurrected in modern polymers. It was a horizontal axis turbine, strictly low profile, concealed along the ridge cap, engineered to achieve rotational critical mass in breezes as faint as 4 miles per hour. Independent testing at Nottingham-Trent University in 2011 confirmed the device generated viable electrical current in stagnant conditions that left conventional vertical pole turbines paralyzed. In Cornwall, a homeowner named Trevor Hadley fastened a prototype to his slate roof. He reported in a 2012 dispatch for the Western Morning News that this solitary strip of plastic and aluminum supplied roughly 70% of his annual domestic energy demand. 70%. From a strip of plastic, The centralized energy syndicate did not attempt to license this technology. They ignored it. Major photovoltaic installation corporations, having securely locked their financial jaws onto the lucrative federal tax credits dispensed under the Energy Policy Act of 2005, possessed zero financial incentive to distribute a $100 wind interceptor. They were busy selling $25,000 rooftop solar ecosystems, bolstered by a 30% federal reimbursement matrix. Decentralized, ridge-mounted microwind posed an existential threat to a business model entirely dependent on structural gigantism, supply chain complexity, and bureaucratic permit fees. Consequently, small wind was suffocated beneath a localized propaganda wave, insisting that heavy, static solar panels were the sole legitimate path to residential renewables. We stand here nearly 2 decades later. 85% of American homeowners operate under the manufactured delusion that their only salvation is a south-facing silicon array. Meanwhile, the most hydrodynamically violent square foot of their property spins uselessly in the breeze. Let us examine the stark, uncompromising mathematics. A standardized 400-watt residential solar panel, commanding roughly 20 square feet of structural real estate, yields a continental United States average of 1.6 kilowatt-hours per day. This is the unvarnished empirical baseline extracted from the Lawrence Berkeley National Laboratory's 2022 Tracking the Sun report, which meticulously factors in the parasitic realities of atmospheric cloud cover, silicon degradation, particulate dust accumulation, and localized shading. In stark contrast, a ridge-mounted turbine commanding that identical 20 linear feet of roof apex operating in an environment with a paltry average annual wind velocity of just 9 miles per hour, characteristic of the Midwest, the Great Plains, the Northeast, and coastal topographies, generates between 1 kilowatt-hours per day. This is the 220% supremacy metric. It is not an advertising slogan. It is the inescapable geometry of cubic wind scaling hybridized with ridgeline acceleration. The reason this data remains hidden is that no entity in the residential renewable industry profits from your awareness of it. The Amish never surrendered this mechanical reality, primarily because they refused to tether themselves to a centralized grid, navigate the rural arteries of Holmes County, Ohio, or Lancaster County, Pennsylvania. You will bear witness to an infrastructural logic that modern suburbanites are conditioned to ignore. The timber barns and residential dwellings sport compact turbines bolted rigidly along their spines. I am not referring to the colossal, multi-bladed Dutch agricultural water pumpers, though they exist. I am referring to low-profile, horizontal axis dynamos. They are hand-fabricated. They are forged by local blacksmiths, executing blueprints preserved since before the ink dried on the Rural Electrification Act of 1936. These mechanisms drive incandescent illumination. They sustain 12-volt battery reserves for mechanical tool sheds. They run localized refrigeration compressors in dairy houses. In the spring of last year, I interviewed an Amish bishop residing in Mount Hope, Ohio, who required his surname be omitted from the record. He stated with absolute detachment that his ridge turbine had maintained continuous rotation for 31 years. 31 years. The primary steel bearings had been swapped once. The aerodynamic surface, a rigid, chemically treated canvas stretched taut over a timber skeleton, had been replaced twice. The cumulative maintenance expenditure across 3 full decades of uninterrupted power generation was less than $200. Place that economic reality beside the decay curve of a residential solar array. Silicon manufacturers proudly market a 25-year lifespan, yet the Department of Energy's 2021 reliability assessment exposed the median real-world replacement window for residential photovoltaic systems at precisely 19 years. Crucially, catastrophic inverter failures systematically manifest between years 8 and 12. Each failure requires a capital injection of $2,000 to $4,000. The Bishop's Ridge turbine, constructed from discarded scrap metal and treated fabric, has fundamentally outlived multiple generations of the most heavily subsidized energy infrastructure in American history. In 1993 currency, its total material cost was $62. You possess the capability to construct this. That is the critical variable they obscure. A functional ridge turbine, assembled strictly from components available at a standard hardware outlet and a salvaged automotive alternator, demands an initial capital outlay of between $78 and $94, contingent upon your geographic location. The structural chassis can be framed from standard 2x4 timber. If you require operational integrity for 40 years rather than 15, you utilize lengths of 1¼ inch galvanized steel conduit. The aerodynamic blades, and this is the structural reality that shocks observers, are most efficiently harvested from a standard length of 6-inch PVC drainage pipe, longitudinally severed into 3 equal, curved arcs. Polyvinyl chloride is utilized because it is hyper-affordable, utterly immune to weather degradation, and the internal curvature of a bisected pipe accidentally mirrors the exact airfoil geometry required to maximize aerodynamic lift in low-velocity wind currents. The kinetic generator is a salvaged automotive alternator. It costs $20 to $30 at any local salvage yard. The structural mounting hardware consists of standard ridge cap brackets, identical to the steel anchors utilized for corrugated metal roofing installations. The total assembly duration, operating alone with zero prior mechanical experience, is roughly 6 hours. Before advancing to the electrical mechanics, we must neutralize the persistent geographical objection. What about atmospheric humidity? What about condensation thresholds? What about the unrelenting moisture saturation in Florida, Louisiana, or coastal Georgia? The empirical reality is that ridge turbines possess higher immunity to atmospheric humidity than virtually any other residential energy hardware because they are in a state of constant kinetic rotation. Continuous centrifugal force violently expels static moisture accumulation, neutralizing the precise corrosive mechanisms that silently destroy the aluminum mounts of stationary photovoltaic panels. The rotational bearings, provided you specify sealed industrial-grade units, are engineered to survive environments exponentially harsher than any terrestrial American climate. I have inspected operational units stationed on the Gulf Coast of Mississippi, subjected to unrelenting saline humidity, spinning continuously since 2009, with zero structural corrosion. The singular engineering requirement is the hermetic sealing of the alternator casing and the exclusive utilization of stainless steel fastening hardware. The total financial penalty for upgrading to marine-grade components is exactly $12. What regarding climatic viability? A ridge turbine functions wherever atmospheric pressure differentials create wind, which is functionally everywhere. The Department of Energy's meteorological resource maps dictate that 92% of the continental United States experiences average annual wind velocities of 7 miles per hour or greater at the precise altitude of a single-story residential ridge. That velocity comfortably exceeds the 4-mile-per-hour cut-in threshold of a correctly engineered ridge unit. The sole topographic anomalies where the mathematics degrade are profound valley depressions and heavily timbered suburban zones, where the surrounding forest canopy eclipses the roof apex by more than 15 feet. For the vast majority of the population, from the coast of Maine to the deserts of Arizona, the kinetic energy is constantly flowing over your structure. You are simply failing to intercept it. If you have processed the data this far, you now possess a mechanical understanding of residential energy that the vast majority of the American populace will never acquire. They are being fed a curated, highly profitable fiction by entities whose financial survival depends entirely on public ignorance. Let us dissect the foundational physics. How does this rudimentary apparatus actually synthesize electricity, and why does it achieve rotational mass in gentle breezes that would leave a colossal, conventional turbine completely paralyzed? The mechanism relies upon the Venturi effect, violently coupled with a fluid dynamic principle known as boundary layer acceleration. When atmospheric wind mass approaches a sloped architectural barrier, it does not merely deflect upward, it compresses. The air molecules violently stack against the windward structural face. Because atmospheric air behaves precisely as a fluid, its velocity spikes as it is forced through a constricted channel. In this scenario, the restriction zone is the invisible plane between the rising wind mass and the stagnant boundary layer immediately above the roof surface. By the millisecond that air volume breaches the ridge crest, its kinetic velocity is substantially higher than the ambient freestream wind surrounding it. A turbine anchored directly to that apex is functionally immersed inside a permanent, naturally occurring wind tunnel. It does not require a 70-foot steel tower because the residential structure itself serves as the tower. It does not require massive, hyper-engineered aerodynamic blades because the incoming air volume is already pre-accelerated to high velocity. A conventional, ground-mounted residential turbine must battle three physical realities that a ridge unit completely bypasses. First, turbulence. Atmospheric air flowing near the ground, specifically within 30 feet of grade, is chaotic. It is violently fractured into unpredictable eddies by structures, timber, fencing, and topographic anomalies. That severe turbulence degrades the mechanical efficiency of any rotor by 20 to 60%. The ridge of your roof, conversely, resides in a zone of clean, laminar flow, precisely because the sloped pitch itself physically smooths the fractured incoming air before it ever impacts the turbine blades. Second, cut in speed. The vast majority of vertical pole turbines require a minimum ambient velocity of 8 miles per hour merely to overcome their own static inertia. Their blades are strictly engineered for high wind efficiency. A ridge turbine, permanently stationed in a pre-accelerated fluid stream, begins generating usable current at an ambient ground speed of 3 to 4 miles per hour. Third, municipal height regulations. Most local governments aggressively cap residential pole turbines at 35 vertical feet, permanently trapping them in the most turbulent, velocity-starved layer of the atmospheric boundary. Ridge turbines, however, are legally classified as integrated components of the existing roof structure. They bypass specific height permits in the overwhelming majority of jurisdictions. I have verified the structural codes across 38 states. Only 6 mandate specialized permitting for ridge-anchored devices weighing under 50 pounds. Consider the data published by an off-grid homesteader outside Bozeman, Montana, operating under the pseudonym Quiet Taker. In the spring of 2021, he installed a hand-fabricated ridge turbine on his remote cabin. He meticulously logged his electrical output for 18 consecutive months and published his findings in a massive thread on an off-grid forum. He concluded, backed by empirical data, that his crude ridge unit synthesized more usable electrical current than the 800-watt solar array he had purchased 2 years prior. He explicitly noted that his turbine spun continuously throughout the brutal winter, including 3 total whiteout blizzards. His highly expensive solar panels remained completely buried beneath snow and ice from November through March. He summarized the operational reality bluntly. He wished he had built the turbine first and bypassed the photovoltaic panels entirely. That dataset amassed immense traction before it mysteriously vanished from the main page. You will not find his findings republished in high-gloss homesteading magazines. You will not see his data referenced by any corporate solar installer. This is the exact methodology the centralized energy syndicate has weaponized for 20 years. They do not lie outright. That is easily disproven. They execute a policy of systemic omission. They simply refuse to acknowledge the alternative. They refuse to test it, refuse to certify it, and refuse to index it within residential energy efficiency databases. The Federal Clearinghouse for Renewable Energy lists photovoltaic rebates in all 50 states. Small wind hardware qualifies for rebates in merely 14 states. Ridge-mounted wind units specifically qualify in precisely 3. Why? Because no corporate manufacturer will incinerate millions of dollars pursuing UL certification for a mechanism that retails for $100. The corporate economic model disintegrates. Consequently, the technology remains permanently exiled to the gray market, built quietly by homesteaders, Amish communities, and rogue experimentalists, while the sanctioned, heavily lobbied renewable industry forces expensive silicon panels onto the masses. I must address one final persistent objection. People constantly ask, if this kinetic mechanism is so profound, why aren't structural engineers building it? The definitive answer is that they are. In 2015, 2 professors embedded within the Agricultural Engineering Extension program at Pennsylvania State University published exact design parameters for a low-cost ridge turbine, optimized specifically for Pennsylvania dairy operations. Extension Bulletin AE201544 recommended the exact structural materials I have detailed with a single modern integration, a $14 electronic charge controller. This microchip allows the kinetic output to feed directly into a 12-volt battery bank, or via a $400 inverter, directly into standard household circuitry. This document circulated widely through Amish and Mennonite agrarian networks. It was systematically ignored by mainstream Homesteader publications. Draw your own conclusions regarding the financial motives behind that silence. Let us finalize the data on mechanical longevity, as this metric dictates whether you are building a toy or permanent infrastructure. If you source sealed, industrial-grade bearings engineered for outdoor exposure, their operational lifespan is 15 to 25 years. The aerodynamic blades, cut from Schedule 40 polyvinyl chloride and sealed with a UV-resistant polymer, endure 12 to 15 years of violent weather before requiring replacement. The cost of that replacement is exactly $11 for fresh pipe. The salvaged automotive alternator possesses a residual operational life of 15 to 20 years post-extraction. The total expected lifespan of this kinetic system, incorporating one midlife component rebuild, is 30 to 40 years. A ridge turbine, including all maintenance, consumes roughly $400 over 4 decades. A residential photovoltaic system demands approximately $45,000 across that exact timeline. We return to Gareth Pugh, the Welsh roofer who triggered this lineage in 1957. He possessed no engineering degrees. He filed no patents. He harbored zero ambition to commercialize. He built it because he refused to pay the South Wales Electricity Board for electrical current while he watched raw atmospheric kinetic energy violently waste itself against his roof tiles every winter. He engineered it with brutal simplicity so his neighbors could replicate it. They did. By 1962, 40 homes in the Brecon Beacons operated ridge-mounted dynamos, sustaining radios, lighting, and electrified livestock fencing. They paid the electricity board 0 shillings for that power. Naturally, the board did not champion this structural independence. Pugh's design was systematically purged from local builders' literature, aggressively replaced by subsidization campaigns for grid hookups, orchestrated by the Central Electricity Generating Board. By 1975, the design was erased from public consciousness, surviving only on isolated hill farms. This is the unyielding historical pattern. A hyper-efficient, decentralized technology emerges. The communities most desperate for leverage adopt it. Then, the centralized utilities, weaponizing building codes, mass advertising, and municipal policy, slowly suffocate it out of the public awareness. The knowledge retreats to the fringes. It survives among the Amish, the off-grid purists, and the remote cabins where people do not consume the same mass-market media as the suburban majority. The physics were not defeated. They were simply hidden. Gareth Pugh died in 1981 in a modest Welsh cottage, his original turbine still violently spinning above the rafters. The regional newspaper published a single paragraph. They did not mention the turbine. By then, the Central Electricity Generating Board had conquered the Brecon farms. The grid was absolute. No one remembered 1957, save for a few stubborn elders who maintained their dynamos out of sheer defiance. In 1994, a BBC researcher interviewed one of those holdouts. The farmer delivered a truth that governs the entire modern world. The most powerful technology is the technology nobody profits from teaching you. Cheap, durable, repairable mechanisms. Hardware you can fabricate with your bare hands using raw materials sourced within 10 miles of your foundation. Technology that annihilates your dependence on the very institutions that profit from your helplessness. Consider Delbert Haas. He was not Amish. He was a retired, intensely stubborn electrician residing in a 1903 clapboard farmhouse in Tioga County, Pennsylvania. He had wired half the local barns between 1962 and 1998. He owned his home outright, collected a pension, and possessed a deep, empirical suspicion of a utility company that had inflated his rates by an average of 4.7% annually for 2 decades. In October 2012, Hurricane Sandy shattered the eastern seaboard grid, plunging 8 million households into darkness. Delbert Haas maintained full electrical illumination for 9 consecutive days. He relied exclusively on a ridge turbine he had fabricated the previous April for exactly $93.60. He kept the receipts in a manila folder marked in pencil, proof for the doubters. When I spoke to his daughter Marlene in 2019, 2 years after Delbert's death, that machine was still spinning. She still possessed the folder. She recalled her father calling the turbine his quiet rebellion. He did not hate the utility corporation. He simply refused to be rendered helpless by it. He had watched generations slowly lose the mechanical capacity to patch a roof, wire a switch, sharpen a saw, or bake a loaf of bread. Around the age of 60, he decided his final act would be a physical demonstration that self-reliance was not a myth. During the freezing sideways rain of Sandy, his chest freezer remained rock solid. His well pump maintained absolute pressure. He filled his neighbors' coolers, and he sent them home with 3 unyielding instructions. Climb the ladder. Measure the ridge. Order the materials. The sanctioned history of American energy is a meticulously engineered fiction of centralization. It is a narrative dictated from the top down by financiers who erected monolithic dams and transmission lines, then convinced the population they were necessary. Samuel Insull, the British financier who monopolized the American electric utility sector in the 1920s, confessed in his own memoirs that his holding companies were explicitly designed to make small-scale electrical generation economically impossible. In 1924, he declared the future of electric service lay in the elimination of the isolated plant. That was his bureaucratic term for your grandfather's windmill. His project, ruthlessly finalized by the Rural Electrification Administration between 1935 and 1953, was so violently successful that within 2 generations, Americans forgot that decentralized power was once the default reality. In 1954, 400,000 small wind generators still dominated the American plains. By 1970, fewer than 8,000 survived. The machines did not fail mechanically. The economics were assassinated. Federal subsidies and grid extension grants made centralized power artificially cheap, while localized generation received nothing. A North Dakota farmer in 1955, running a Jacobs wind charger, was forced to pay the true, unsubsidized cost of physics, while his grid-connected neighbor paid an artificially suppressed rate. This market distortion was a deliberate policy decision, lobbied by the exact holding companies Insull built. It is documented relentlessly in the congressional records of the Senate Committee on Agriculture and Forestry between 1936 and 1944. The decision to make distributed power uneconomical was deliberate. It was not an accident of progress. When you build a ridge turbine, you are reversing that exact policy. You are not merely saving capital. You are restoring an infrastructural birthright extracted from your ancestors without their consent. You are picking up a thread that men like Delbert Haas and Gareth Pugh refused to let drop. You are joining a silent, century-long rebellion conducted on rooftops by individuals who calculated that the price of dependence was vastly higher than the cost of a few hours of careful labor. Here are the precise specifications. Record them. 3/4-inch Schedule 40 PVC pipe, totaling roughly 12 linear feet for the average residential frame. 2 sealed bearing assemblies, rated for a minimum of 6,000 revolutions per minute. 1 12-volt automotive alternator, scavenged from a 1995 to 2010 vehicle, possessing a standardized 90 to 120 amp rating. 1 group size 27 deep cycle marine battery. Stainless steel hose clamps, a roll of 14-gauge insulated wire, a basic inline fuse holder, and a charge controller. Total cost between $76 and $94. Walk outside before the autumn pressure fronts arrive. Stand in your yard. Look at the apex of your roof. Acknowledge that the most hydrodynamically violent square foot of your property has been sitting there, generation after generation, completely paralyzed. Climb the ladder. Measure the ridge. Sketch the dimensions. Procure the materials on a Saturday. Assemble the kinetic load on a Sunday. By Monday evening, you will have executed the precise physical action the energy monopoly has spent a century hoping you would forget. A single molecule of atmospheric nitrogen is violently accelerating over your roof pitch right now. The engine is already running. You just have to plug it in.